Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for this morning, it will be a continuation of my long video format topic, analytic geometry. Uh, I am now, or we are now, on lesson number 3. For those of you who are following my channel on the topic analytic geometry, we are now on lesson number 3. Okay, let's proceed. The subject matter for this morning will be a long video format, and the title of the topic will be Analytic Geometry Lesson number 3. We are running smooth, okay? And the title of the topic will be How to Plot the Intercepts. Intercepts meaning, under the Cartesian, it could be the x and y intercept. To show you the x and y intercept considering a straight line for the meantime. Straight line. We are given a straight line. This straight line here passes through this point here. And at this point, okay, the first intersection is actually the y-intercept. Y-intercept, because it passes the y-intercept at this location here. The y-intercept is actually the vertical axis, right? And the other passage is actually the so-called, where it passes the x-intercept, it is just at this point here. Okay, as an example, considering a straight line for the meantime, it's the so-called x-intercept. So, the title of the topic for the meantime is just how to plot the y and x-intercept. Okay. For the meantime, we are considering only a straight line because if the graph is not a straight line, the intercepts are actually different. Okay. There could be many. If the equation is a quadratic equation, there could be two or one more than the, what you call this, it could be more than one y-intercept and x-intercepts. It depends on what kind of equation it will be. But for tonight, just to simplify the concept on how to plot the intercepts, considering the y and x-intercept, we are considering for the meantime a straight line. Okay? So to base illustrate the x and y-intercept, we are considering for the meantime a straight line. Okay, this will be the figure of the given problem. I will go back to this as soon as I discuss the problem. What is given here? To illustrate the what you call this, the plotting of the x and y intercept, we should be given an equation. So for the meantime, we are given an equation. The equation is actually y equal to 3x plus 4. It is a linear equation. The highest power of y is 1 and the highest power of x is 1, so this is linear. Right? If it is linear, under the study of analytic geometry, this should be a straight line. Okay? So for the meantime, we are to plot the graph of a straight line. And the problem will be asking where is the location of the y-intercept and the x-intercept, and the discussion will be on how to compute for the coordinates of the y-intercept and x-intercept. Okay, so the problem is asking what will be the x-intercept. X-intercept meaning what will be the coordinates of the x-intercept. Y-intercept, what will be the coordinates of the y-intercept. As an additional to the topic for tonight, what will be the slope of the given straight line. It is a straight line as an example for tonight, right? And plot the graph. Okay, so to best illustrate the computation of the coordinates of the x and y intercept and so with the slope, we'll proceed with the solution. Okay, let's try to bring out the solution. The given straight line is y equal to 3x plus 4. To find for the y intercept, This is the rule. It will not change. As long as we are solving for the y-intercept, this is the rule. We set x equal to 0. Why we set x equal to 0? Because at the location y-intercept, right, the vertical thing, the vertical axis, the abscissa at this line here is actually equal to 0. Abscissa. It is not to the right, it is not to the left, so the value of the abscissa at this vertical axis here is x is equal to 0. So when we set x equal to 0, we could compute for the corresponding value of y. Like what I said, the proper procedure on how to compute for the y-intercept is to set x equal to 0. It is this. Sorry for that one. It is this one. We set x equal to 0. If we set x equal to 0, we could compute for y. Okay, so we'll go back to the given equation. Y now, we're following this, right? This y. Equal to 3 times 0. We set x equal to 0 to find for the y-intercept. 3 times 0 plus 4. So y now will be equal to 4. Meaning to say, for the given straight line, when we set the value of x equal to 0, the ordinate at the point of intersection on the y-axis is actually at the location y equal to 4. 1, 2, 3, 4. So the coordinates of the y-intercept is actually at 0 and 4. Where did we get the 4? As per computation, after setting x equal to 0, y is equal to 4. So, like what I said, the coordinates of the y-intercept will be at the location 0 and 4. It is this. Oh, that will be our answer. What's happening? I must have to buy a new pen now. I got so many pens inside, right? I'll be using this old one. So, this will be our answer. Right? The coordinates of the y-intercept will be at the location 0 and 4. 0 and the ordinate will be 4. So this point here is termed to as the y-intercept. Okay, our topic is intercepts. The location is actually at the coordinates 0 and 4. Okay, as easy as that one. Okay, that's the procedure on how to compute for the y-intercept. To compute for the x-intercept, we will set y equal to 0. Why do we set y equal to 0 to find for the x-intercept? The x-intercept is actually a point on the x-axis where the line crosses, right? It is at this point here. So, if a point lies on the x-axis, the ordinate is actually y equal to 0, right? On the x-axis, the ordinate is 0. So, if we set y equal to 0, we could compute for this one. So, for the computation of the x-intercept, we set y equal to 0. And this will not change. For as long as we are solving for the x-intercept, we will set y equal to 0. For it to be called the x-intercept. So, going back to the given equation of the straight line, y equal to 3x plus 4. Okay, we set y equal to 0. So this should be 0 equal to 3x plus 4. X now will be negative 4/3. Okay? So the location minus 4/3, the abscissa will be minus 4/3. And the ordinate 0 is referred to as the x-intercept. It is at this point here. This point here. At the location minus 4/3, minus 4/3 is actually to the left of the vertical line or the y-axis, negative 4/3, right? And negative 4/3 and the ordinate is 0. Okay, that's the coordinate of the x-intercept. And at this point here is the so-called x-intercept. Okay, the topic is intercepts. We know how to plot x-intercept, y-intercept. So, how to plot the x-intercepts. That's our main topic for tonight. As an additional thing, okay, we now plotted the y-intercept and the so-called x-intercept. The problem is asking what will be the slope. what is M? The last time around under lesson number 3, I presented the formula on how to compute for the slope. Okay? The slope is actually y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It is represented by this one. Okay? But we must have to specify which point is which point are P1 and P2. So I place it here. I put the location minus 4/3 and 0 to be P1. Okay, this one. The x-intercept, I represent that as point P1. And the y-intercept, I represent that as point P2. You could interchange if you like, but for me, I make this one as P1, and P2 will be the y-intercept. So P1, the coordinates will be negative 4/3 and 0, meaning to say x1 will be negative 4/3, y1 is 0. Point P2 is the y-intercept. It will be at the location 0 and 4. At the location 0 and 4, okay, x of 2 will be 0, the abscissa is 0, right? And the ordinate will be 4. Abscissa will be 0, ordinate will be 4 at point P with the subscript 2, right? So we are now given the subscript by using this formula. So substituting now, y sub 2 will be 4, so this is 4 minus y sub 1, which is 0, y sub 1 is 0. All over, x sub 2 will be 0, the operation is subtraction, minus open quantity. X sub 1 is negative 4/3. I place a quantity here because we are subtracting a number which is presented by negative sign. So open quantity, negative 4/3, close quantity. Okay. I will remove first this one. Okay. 4 minus 0 will be 4. 0 minus minus, the numerator now will be 4/3. Okay. So we are simplifying now. This is now algebra. We must have to eliminate this 3 here. We will multiply the numerator by 3 and we will multiply the denominator by 3. So on the numerator, or denominator rather, 3 and 3 cancels. Okay. 4 times 3 will be 12. 3 over 3 is actually 1 times 4 will be 4. So 12 over 4 will be equal to 3. So the slope is actually equal to 3. And this is plus. The significance of the plus 3, meaning the slope is actually upwards to the right. This is, so I place it here, upwards to the right. Meaning to say, the straight line is tilting to the right, upwards to the right. And the slope of this one, with respect to the horizontal, is m is equal to 3. Okay, that's it, guys. That's the way how to plot the x and y intercepts and to compute the coordinates of the x and y intercepts. Okay, how to compute for the slope as an additional thing and plot the graph. Okay, as a general rule on how to compute for the y-intercept, this is the rule. We set x equal to 0. This will not change. For as long as you are solving for the y-intercept, you set x equal to 0, then solve for the corresponding values of y. And for the x-intercept, we will set y equal to 0. Okay, as simple as that one. Okay, for those of you who would like to subscribe or watch my long video format topics on my channel is at youtube.com/Prof. David J. De Los Reyes. If you want to share it, please click share. I am assuring you, you will learn something from it. Okay, good morning from Los Angeles.